Awesome. Wonderful. Hello. Thank you for joining me for the explanation of number 26 from section 1.5, problem number 26. If you showed up to class and we were working on this towards the very end, and I told you to come check out the YouTube video after, this is the YouTube video, okay? So thank you again for joining and seeing how I work out this problem. Now, a few things to talk about first with this problem. Number one, we have to solve for y, okay? We have to solve for the inverse. I already put it in inverse form written up there in the top left corner. So this is already in inverse form. We have to solve for y now. Number two, okay, if you remember in class, I started to take the natural log of both sides, okay? And I started to ask, am I okay to do this? Can I do this? The answer is yes, right? In other words, if I have 5 equals 5, right, I can take the natural log of both sides, right? Ln of 5 and ln of 5. Sorry, I will rewrite it over here, right? And that still holds true. In other words, okay, this value and this value is the exact same. So that tells us if we take the natural log of one side of the equation, we can take the natural log of the other side of the equation. Now, I had to stop because we were running short on time, but I have all the time in the world to work on it now. So that is what I'm going to do. But to get there first, we have to rearrange this equation into something that will work a little bit better for us, okay? So I'm going to go ahead and just put, oops, I apologize. I'm going to go ahead and put some parentheses around these terms, okay? We're allowed to do that just to make things a little bit clearer, okay? When we're dealing with fractions, okay, and you're trying to solve for a variable, fractions can get really messy. Let's get this out of here, okay? Let's multiply the top let's multiply both sides by a 1 plus e to the negative y. All right, that is an e like that. Okay, what we do to one side, we have to do to the other. So this is times on top here, 1 plus e to the negative y. Like that, okay? I'll put parentheses around it. Now, what can we do? We can cancel these out just like that. Let's rewrite our expression. We have 1 plus e to the negative y all times x is equal to 1 minus e to the negative y. And I'll write it like that. Now, the next thing that we want to do is we want to get all like terms onto one side. Or, in other words, we want to solve for the given variable by getting that same variable all by itself. Well, how can we do that? Let's multiply this x through everything, right? And let's see if we can get the negative y's all on one side. In doing that, we will see that we get x plus e to the negative y times x, right? So I just multiplied that x through, is equal to 1 minus e to the negative y, like that, okay? Now we're here. Now we're in a much better spot, okay? I'm going to go ahead and subtract this x to the other side, like that, and I'm going to add this e to the negative y to the other side, okay? So I'm going to subtract x, right? So this is minus x on this side, right? Hopefully you see how I did that. And then I'm going to add this e to the negative y to the other side, okay? So this now becomes e to the negative y plus e to the negative y times x equals 1 minus x. So I will rewrite it just like that, okay? I'm going to go on to the next page here, and I am going to continue working with this. So again, make sure you have all of this written down. I'm going to go on to the next page, like so. So we said we have e to the negative y plus e to the negative y times x is equal to, I believe we said 1 minus x, correct? Awesome. All right. Now we're here. Now we can factor out an e to the negative y. That is an e like so. So up to this point, all we've been doing is just some algebra skills, right? Getting things out of the denominator, multiplying and getting the like terms on the same side, all right? If we factor out this e to the negative y, right, we can rewrite this expression as e to the negative y times 1 plus x, right? Because we still have that x there, is equal to 1 minus x. All right, we said we wanted to have e to the negative y all by itself. Let's go ahead and divide. If we divide 1 plus x, right, because these two terms are multiplied by each other, that cancels out. We divide this side times 1 plus x. Okay, we can now rewrite this expression as simply e to the negative y is equal to 1 minus x over 1 plus x. right? These cancel out. We are left with 1, technically, 1 times e to the negative y. So we are now at this step, e to the negative y. Now, in the lecture video, I kind of jumped the gun a little bit, and I started to take the natural log of everything before simplifying it out. Would it have still worked? Yes. Would it have been very messy? Yes. This is a lot easier to solve. Now we can go ahead and take the natural log of both sides. So if we take the natural log of e to the negative y, okay, we take the natural log of 1 minus x over 1 plus x, okay? I'll try and rewrite this a little bit cleaner. Now we have these two expressions, they're equal to each other, right? Can I do this? Yes. Why? Because think back to that simple expression, right? 5 equals 5. We have stuff on both sides. ln of 5 is equal to the ln of 5, right? So we know that we can take the ln of both sides. Like so. Perfect. So this holds true. Now is when we start to work with our log properties, okay? We have an exponent. We have e raised to an exponent, okay? Think back to our log property rules. If you're not familiar with them, please brush up on them. I believe they are in section 1.4 or 1.5, right? Whichever homework assignment we talked about it. But regardless, we can pull this exponent into the front, right? We can rewrite this as negative y times the ln of e is equal to the ln of 1 minus x divided by 1 plus x. Sorry, I made a little mark there. Oops. Okay, all I simply did, pulled that exponent, pulled it out to the front. We're allowed to do that. Now, what can you tell me about the ln of e right here? This is the ln of e, right? The ln of e, they cancel each other, right? The ln of e is just 1. So we can get rid of this now, right? See how we simplified that down really nicely? We now have negative y times 1, but I'm just going to leave it as negative y, right? Is equal to the ln of 1 minus x over 1 plus x, okay? I'm going to rewrite this one more time. We have negative y is equal to the ln of 1 minus x over 1 plus x, okay? Like this. Okay. How do we solve for y? We're almost there. Divide by a negative, right? Divide by negative 1. We divide by negative 1, boom, those terms cancel out, right? What we do to one side, we must do to the other. Divide by a negative 1, okay? Now this expression becomes y equals negative ln of 1 minus x divided by 1 plus x, okay? Are we done? That is a great question to ask yourself. Did we solve for y? Technically speaking, yes, we did. Is there a way to simplify this even more? Yes, okay? We have a negative sign out here in the front. Remember our log property rules? If we have anything on the outside, right, that we can take and put it to the inside, and that becomes that becomes our exponent, right? In other words, how we basically took the negative y that was in the exponent and pulled it out of the ln, well, we have a negative 1 here, okay? If you can see it, right, oops, there is this negative 1 times ln, right? That negative sign. We can go ahead and write that into our expression. So I'm going to factor that negative 1 in, and you'll see how I will do this, okay? This is now 1 minus x divided by 1 plus x, all to the negative 1 power, right? And yes, the exponent goes not just to the top term, to both terms, right? It applies to everything inside of the natural log expression. Now, we have an exponent to the negative 1. What does that tell us? Anything to the negative 1 power, that is simply just 1 over that quantity to the positive 1 power. In other words, all we do is we flip, right? We flip this fraction so it becomes the natural log of 1 plus x divided by 1 minus x, okay? Now we have solved for y. This is our final equation right here. I will go ahead and box this a little bit neater. There we go. Okay, this is our final expression. Y is equal to the ln of 1 plus x divided by 1 minus x, right? And keep in mind, we cannot take the ln of negative numbers, right? So this is indeed our final solution. So a few things to keep in mind about this problem. Number one, right? When we see e's, or like when we see exponents, right? E to the whatever it is, right? E to the x, e to the y, right? Or if we're just dealing with exponents in general, it doesn't have to be e, right? This could be 5 to the 2x minus 3, right? Is equal to something, right? Let's say it's equal to y, right? We can take the ln of both sides, and we probably should, because when you have exponents, right, the easiest way to get those exponents out of there, right, out of the, in other words, to get rid of this exponent so that we can like solve for x, right? Or if we're taking the inverse of this, right? Take the ln on both sides, right? The ln of 5 to the 2x minus 3 is simply written as 2x minus 3 times ln of 5, hopefully everyone can see that, is equal to the ln of y, right? Now we can solve for inverse. So just keep that in mind when you're solving and you see exponents, especially natural logs or e's, right? Just know if you see e's, we're probably taking the natural log at some point throughout that process. If you see natural logs, there's a good chance that we're going to want to raise everything, that we're going to want to raise e to the power of everything, right? So that way those e's to the ln's, they cancel each other out. Other than that, thank you for checking out this explanation. Hopefully that helped. Let me know if you have any more questions. Feel free to reach out to me, email me, or show up to office hours. Thank you, and have a wonderful rest of your day.